All right, we're back here finishing up section 8.1. We're going to be talking about interpreting confidence level. Now, to interpret a confidence level C, say, if we were to select many random samples from a population and construct a C% confidence interval using each sample, about C% of the intervals would capture the parameter in context, like the mean would capture the mean or the standard deviation, whatever we were looking for. All right, so let's look at this. As we say, 2 weeks before a presidential election, a polling organization asked a random sample of registered voters the following question: if the election were held today, would you vote for candidate A or B? Now, based on this poll, the 95% confidence interval for the population proportion who favor candidate A is from 48% to 54%. Now, the confidence level is that we would talk about it here as we would say if we were to select many random samples of the same size from the population of registered voters and construct a 95% confidence interval using each sample, about 95% of the intervals would capture the true proportion of all registered voters who favor candidate A in the election, okay? So this is kind of what we're talking about. Here's what the true population or true mean is right here. As we were to do these samples, we'd have these intervals, and what we would see is that these are samples. Yeah, here's where it actually captures. Here's where the center is, but you notice how it's still capturing the true mean. This one did not. This interval did not. So what we're saying is that 95% of these intervals are going to capture the true mean. We're going to get some that don't, if we're to do a certain number of those. So that's one thing to keep in mind. Now, again, one particular confidence interval is calculated, or once it's calculated, its endpoints are fixed. And because the value of a parameter is also a constant, a particular confidence interval either has the parameter, includes the parameter, or it doesn't. So it's where the probability is 1 or 0. Okay, so the confidence level does not tell us the probability that a particular confidence interval captures. So if we say it's a 95% confidence interval, that doesn't mean it's a 95% probability that we're going to capture it. We're just going to say that 95% of the intervals do capture it. It's a little bit different, okay? Now, on a given problem, you may be asked to interpret the confidence interval, the confidence level, or both. Be sure you understand the difference. The confidence interval gives a set of plausible values for the parameter, and then the confidence level describes the overall capture rate of the method, okay? All right, so now in general, we prefer an estimate with a small margin of error. We want it small. Now, the margin of error gets smaller when a couple things. The confidence level decreases. So if I go from a 95% confidence level to an 80%, well, yeah, the interval is going to get smaller, which reduces our margin of error. Okay, in order to be 99% confident, we're going to have to increase that level, which of course increases our increases our margin of error. Now, so to attain a smaller margin of error, we have to be willing to go less confident. All right, now the other part is to increase the sample size. And we've talked about that many times. The bigger the sample size, the more accurate we are. And so that does reduce the level of our margin of error. And again, we talk about that proportion. For proportion or mean, it's proportional to 1 over n. So if we quadruple the sample size, so if we make it 4 times bigger, square root of 4 is 2, so it's going to cut the margin of error in half is what it's going to do. Okay, so now the margin of error does not account for any sources. There might be some bias in there, so remember those sources of bias that we talk about. That could incorporate some of that error as well. Okay, now for a normal sampling distribution, extending about 2 standard deviations should put this into a 95% confidence. So remember that if it's normal. All right, and if we go out to 3, that should put us in 99.7% confidence interval, okay, because based on our normal distribution that we talk about, okay. Now, the more general formula for a confidence interval, it's basically your statistic plus or minus your critical value times the standard deviation of the statistic, and that critical value is a multiplier that makes the interval wide enough to have the stated capture rate. That's kind of what that does. All right, so here we go. As part of a project about response bias, Ellery surveyed a random sample of 25 students from her school. One of the questions in the survey required students to state their GPA, to tell them out loud. Based on the responses, Ellery said she was 90% confident that the interval from 40% to 72%, the proportion there, captures the proportion of all students at her school with GPAs greater than 3.0. Now, what would happen if we, to the length of the interval, if the confidence level, if we increase that to 99%? Well, we know what's going to happen when we increase that confidence level, we know that the length of the interval is going to have to get bigger. It's going to go wider than 0.4 to 0.72. Okay, in order to be 99% confident, it's going to have to. All right, so again, it would be wider because increasing the confidence level increases the margin of error. Now, how would the width of a 90% confidence interval based on the sample size of 100 compare to the original? Now, again, we're increasing the sample size from 25 to 100, so that's 4 times bigger, so it would make it, the confidence interval would be half as wide. Okay, we reduce that margin of error by half on that. So that's kind of a nice way of increasing or decreasing your margin of error, I should say. All right, now C, describe any potential source of bias. One of the things I would say is that when you ask people to say it out loud, they might not tell you the truth. Okay, if it's anonymous, they're probably more likely to tell you the truth. But if you're asking someone face to face, and they might be a little embarrassed if their GPA isn't higher than 3.0, so they might lie. So you might have some margin of error based on not being truthful. Okay, I always want to make sure that they're anonymous when they do that. Okay, so rounding out the section here are our learning targets that we've had. Hopefully we can do all those. There's some nice problems on 550, 11, 15, 17, 19, 21, and don't forget those multiple choice 23 through 26. Those are fantastic problems. That wraps up section 8.1. Until next time, I'm Mr. Boone.